SwayamPrabha. Digital India. Educated India.
Welcome to today's lecture. We are continuing our discussion on the mineral deposits, Indian mineral deposits, and in the process we saw deposits of iron, copper, tin, and while discussing the geological provinces, the Singhbhum craton, the Dharwar craton, and the Bastar craton, and we just last class we are just discussing about the Singhbhum shear zone as an example of a metallurgic where there are mineralization of copper, molybdenum, some nickel, and more prominently uranium deposits occur all along that shear zone, which runs for about 150-160 kilometers in an arcuate shape, where we are faced with the problem of the source of the metal, where the uranium could have a very obvious source of the granites which are in close proximity and which could have given rise to a hydrothermal fluid, and mineralization must have brought about by deposition of uranium when the conditions must have been oxidizing. Copper possibly could have been derived from the basic units like the lavas, basic lavas which occur nearby areas, or also could be the granitoids could have been sourced for the copper. And because of their close association, this copper, uranium, and occurrence in close association with granitic rocks, in addition to the earlier held view of hydrothermal origin structurally controlled on a shear zone, these deposits also do have a prospectively could be called as could be labeled as iron oxide copper gold deposits, although the very basic idea of iron oxide copper gold deposit occurring in granitoids associated in the quaternary interior does not quite satisfy to the condition of Singhbhum shear zone. This will possibly wait a lot of more study. So, let us move on to the lead and zinc resources, where we have the three dominant types: the sediment hosted massive sulphide deposits, the volcanogenic massive sulphide deposit, and the Mississippi Valley type deposit. The last one, which is put on a white box here, is presumably absent in the Indian context. Deposit of volcanogenic massive sulphide affiliation of the type of the most well known lead and zinc source, which is essentially the Kuroko type, which are also geologically pretty young. Such deposits as of now are not reported in the Indian context, although as we will be discussing about the Aravalli craton, some occurrences in the South Delhi fold belt with some of the features coming to knowledge could possibly be prospective candidates to be included in that. But we will discuss the Aravalli craton in terms of its well known metal potential of lead and zinc in the Aravalli fold belt. So, here is the Aravalli craton, which we have already discussed about the North Delhi fold belt hosting the Khetri copper deposit. Here is the Madan Kudan, and this is Khetri. This is the area where it is hosted by the rocks of the Alwar and Ajabgarh group of rocks of Delhi supergroup. This is the South Delhi fold belt. Here there is this well known deposit of Ambaji and Deri, which was essentially originally known as a hydrothermal deposit, and I would like to draw the attention to these areas where we have a number of important occurrences producing the most of the lead zinc in the country, and the one which is over here, which is the Rampura Agucha deposit, which is one of the richest zinc deposit of the world. And here is the Rajpura Dariba deposit, this is the Jawar deposit. So, all along we have the lead and zinc deposits which belong to the sediment hosted massive sulphide SMS or the SEDEX type of deposit as far as their characteristics are concerned. And this is a the Aravalli cratons metallogenic potential is quite high. Here is the Trans Aravalli region in which we see a lot of later granitic activity, and this is the area where the deposit of possibly the only occurrence of a skarn tin skarn deposit in Degana in the state of Rajasthan occurs here. These are the Trans Aravalli Malani suit of rocks, and there are many such other important occurrences here which we are not coming to, but we would conclude on the Aravalli craton, its metal potential in terms of the lead and zinc. It is always good to see some of the cross sections for a better understanding. So, this map has been taken from a source as mentioned here. This is the Rajpura Dariba deposit where the plan is shown here, and it is the section where we could see the ore body which is within the major of the ore body in the carbonate rocks, where it is a siliceous dolostone, and this is the major ore body is occurring here, and here it is graphite mica schist, and hosted by here is the mica schist with storolite porphyroblasts, and this is a section of the Rajpura Dariba ore deposit which is more or less would look almost quite close to what we have seen in some of the classic deposit like Sullivan in Canada, although the setting will be different. Here it is metamorphosed country rock here. The deposits do exhibit the very well stratified, well stratiform characteristics, although in the mineralization in Rajpura Dariba it has been proposed that the mineralization has taken place in two stages. The early stratiform ores were later on overprinted by a later phase of hydrothermal activity, giving rise to the vein ores, and those situations where the mineralization of mostly the arsenic antimony bearing phases, mineral phases came into existence, and mostly formed in the later stage of mineralization. And so, in a way, if we summarize the Aravalli craton scenario, then the Rampura Agucha is the most important one with lead zinc silver deposit in India. And needless to mention that most of these deposits that we have discussed in this SMS category, and also some of the other deposit like for example in the Singhbhum shear zone or in Khetri, these deposits essentially which are the copper deposits, they do also contain some gold and silver which come as byproducts, adding to the total production of gold in the country. And the Rampura Agucha deposit is most important with a good amount of reserve, and as I said, the zinc is one of the richest zinc deposit in the world, where the zinc concentration can go to 13.6% to 8% at the maximum. The hosts garnet biotite silmanite gneiss, and this deposit also has a distinction being in the highest grade of metamorphism rock, where we get the almost like amphibolite grade metamorphism, garnet biotite silmanite gneiss with bands of calc silicate rocks, and also with graphite mica silmanite. The ores are sphalerite, pyrrhotite and pyrite galena, and the available geological information indicates that it is a sediment hosted mineralization and localized by anoxic environment. In the Rajpura Dariba sector, the metamorphosed siliceous dolostone and graphite mica schist are the main host rocks, and it is a sedimentary exhalative type of deposit, preserving all its characteristics in the form of sulphide rhythmites, where the hand specimen of the ores, where it could be very clearly seen the sulphide layers being conformable with the classic shale layers. The Zawar deposit is mainly hosted by dolostone with phyllites and slates, mica schists, and the localization of ore is structurally controlled along shears, and the initial mineralization is believed to have taken place during sedimentation and early diagenesis, with the bulk of the mineralization being translocated extensional fractures and shears during later deformation, because we visualize that these deposits essentially originated from intercontinental reef type of sedimentary basins, and which also subjected to later stage of deformation. Well, I mean, even though we are not going to much into the details of it, this is the scenario of the diamond occurrences in the country. We could see from the red dots that they are localized, they mostly occur in the Dharwar and the Bastar Craton, and if only the lone locality here in the Vindhyan, boundary of the Vindhyan and the Bundelkhand Craton. Going by the way the diamond bearing kimberlites originate, we have seen that they will only be occurring in the parts where there will be a thick continental crust, and where the intrusive, where the extrusive body in the form of the kimberlite pipes will be bringing them up from the deeper part, where the diamond stability field in the upper mantle. So these are the ones in Panna, in Vajrakarur, and in this is the Krishna. This is a lamproite, and so the point that basically we made here, that of late these cratonic blocks where there have been a few discoveries, but their potential in the context of occurrence of diamondiferous kimberlites, and they provide ample opportunities for further exploration, and they seem to be having high potentials in terms of the occurrence of diamond bearing kimberlites. Okay, we will have a brief overview of the uranium mineralization in the country, which is critical and which is also is of a very strategic importance. And we know that this is one of the metals for which maximum exploration efforts are being made, and the governmental agency like the Atomic Mineral Directorate of Exploration and Research have been putting a lot of effort in exploring for for uranium resources in the country, and there has been some amount of success in the recent past, as we could see here. Before that, let us see the different genetic types of deposits that we have seen for uranium. The paleoplacers like the Witwatersrand type, unconformity like the Athabasca basin and Alligator River in Australia, and some important deposits, and they happen to be the richest amongst the uranium deposits of the world. The tabular sandstone hosted deposit, the roll front type and the vein type. Vein type we have already seen occurring in the Singhbum shear zone, where the mineralization is in the main Singhbum shear zone within the schistose country rocks, and roll front type deposits are as yet not very well reported in the Indian context, but the unconformity and some of the deposits do seem to have the affinity towards a unconformity type, and one such could be a tabular type sandstone hosted deposit as you see in the Colorado Plateau. So these are the areas. This is the Singhbum shear zone, which is already discussed. This is Kadapa basin on the northwestern and the south part of the Kadapa basin. There are two important occurrences. The northwestern part is the Sisailam, Palnad and the Kurnool sub-basins of Kadapa basin, and here is the southern part of the Kadapa basin. This is the Bhima basin in the where there is also a report of uranium. Kaladgi basin. This is the North Delhi fold belt, which we just discussed in the context of copper, and this is the one which is from the Mahadek basin in Meghalaya. So, these are the areas in which mineralizations of uranium has been reported in different, they do exhibit diverse lithologies and geological setting. We will just see some of them. So, the characteristic in the northwestern Kharagpur basin is that these are of Proterozoic age, formation in the middle Proterozoic age, and they are unmetamorphosed orthoquarsite and limestone and shale. There are low grade, low tonnage deposits. Generally, the most of the deposits they occurring, they so far discovered in the Indian context, they do not happen to be as rich as we see in many of the deposits, world type deposits. Like for example, in the deposit which are hosted in the Singhbum shear zone, the grade possibly goes in the level of 0.04 or 0.05, 0.08 or at the most 0.1 weight percent of U3O8, mostly in the very low grade. So, those are the types of rocks or the ores which are only delineated on the basis of the intensity of the gamma ray that comes out of the during the radioactive integration, and they are identified as ore on the basis of that, and the ores are treated by acid leaching process, and the finally recovered in the form of the magnesium diuranate, which is the yellow cake, and such kind of. So, this uranium mineralization in the Singhbum shear zone, like in the one in Jadugoda, there the dominant process of extraction is through acid leaching. I will just cite why this is important, because when the host rock type varies, that becomes a, so the technology has to be different, or the different methodology has to be adopted for recovery of the uranium. So, here we see a nearly 60 square kilometer area unexplored. There are still some scopes of discovery of such type of deposits here, and the genetic type is not very well known here. So, this is the Tumalapalli deposit in southern Kharagpur basin of Andhra Pradesh. So, here it is as interesting could be seen here. The red line is the ore band. There are two bands of ore containing uranium mineralization here, within dominantly chatty limestone and massive limestone. So, here is a deposit where it differs from the deposit which we saw in the Singhbum shear zone being hosted by limestone. So, it is a tabular strata bound non transgressive ore zones, homogeneous. The mineralization extends for over 160 km along the strike. The limited variation in grade and thickness. There are two ore lodes which is shown here, separated by 3 meter. Basic dikes which lie in the center of the deposit is not disturb the continuity of the mineralization, but they are there. So, this deposit, as I was discussing, has posed the problem of recovery, because it cannot be, the ore cannot be recovered by acid leaching process. So, there was an alkali leaching process which was devised for recovery of the ore of uranium from this ore here. The North Delhi fold belt, it is intermittently along a 320 km long east west trending Kaliguman lineament. The North Delhi fold belt lies in the north part of the lineament. This comprises this Khatri Alwar and Lalsot Bayana subbasins which we just saw before, and these are middle Proterozoic, and there has been extensive albitization. So, it could possibly be still be coming under the hydrothermal type of mineralization here. And this is the in the Kaladgi basin, this is the Gogi project in Bhima basin in Karnataka. This is small medium grade deposit. Here the mineralization is associated with tectonized limestone, sheared basement granites. The mineralization in the environments of thrust plain and unconformity, and coffinite and pleaseband are major uranium minerals. Mineralization is intimately associated with carbonaceous matter, which we could possibly make a comparison of the situation of unconformity related deposits, where the mineralization has to there has to be a carbonaceous horizon for the deposition of the uranium as UO2 as +4 state, and so this deposit looks to be somehow a little close to the unconformity deposit, where it is associated with the thrust plane and unconformity. This is the uranium mineralization in the Mahadek Basin, Meghalaya, and this, from the setting, geological setting and the lithological association, it has a close correspondence or a kind of a similarity with the tabular type deposits hosted in sandstone, which you see in the Colorado Plateau. Here the mineralization is hosted by arkose to subarkose feldspathic wake associated with organic matter and pyrite. Organic matter becomes a very favorable locale for deposition of uranium in the form of UO2, and the ore body is tabular and occurs within a vertical depth of 50 meter. Total of 9,500 tons of uranium oxide containing 9.22 million tons has been reported here. So, here the grade is about 0.104%, almost going to about 1000 ppm of U3O8 with a thickness of 4.07 meter, and so this is the scenario as far as the uranium mineralization of the country is concerned. So, this brings us to a close of discussion on the Indian mineral deposits, and as you could see, it has not been very exhaustive discussion. There are many other occurrences which we could not discuss because of the within the time frame, but what basically the insight that we acquire from here is that the Indian subcontinent in totality or the peninsular India in particular, there are lots of areas who have a much higher potential for occurrence of many of the metals like the base metals copper, lead, zinc, gold, and of course we did not discuss about the chromium. This is the important deposit, which is the chromium deposit, which occurs in the Singhbum craton, as I mentioned, on the northern and southern extreme, where in the northern extreme it is very close to the Singhbum shear zone, where it occurs in the form of the ultramafic bodies which have the chromite occurrences like in Roro-Buru area in Jharkhand, and the southern part where just about the southern extreme of this Singhbum shear zone, we get a huge ultramafic complex in the Sukinda area, which is essentially an area where it is it is actually the major source of chromium, and that puts us into a convenient situation of being 5th largest producer of the metal in the world. And not only that, the Sukinda area also are a major prospects for nickel there, which we saw in the process of the residual concentration process, where the nickel gets enriched in the form of the nickeliferous clay, which are very much present in the Sukinda Nausai chromite belt of Odisha, which is the southern part of the Singhbum craton. And not only that, the belts are also very actively being worked for platinum group of metals, and some progress has already been made in that. So, we do have a lot of prospects of producing these metals in near future, the platinum group of metal, nickel from the ultramafic complexes of Sukinda Nausai area. And so, we see a wide diversity in the age distribution, where most of the deposits are belonging to the Archean, the Proterozoic, the metal deposits, and bearing, and also mention also has to be made about the important mention has to be made about the east coast bauxite, which is a result of residual concentration process, and which has given rise to huge bauxite accumulation on the east coast of eastern coast of India, and the aluminum being mostly derived from the aluminum rich chondritic source rock. And there are many other deposits, other occurrences. Say for example, the Saucer mobile belt, the Saucer group of rocks producing the most of manganese in the country, and also if we do not mention about the our beach placer deposit, it would not be a complete idea about the mineral potential of our country. The we get the beach placers deposit in the country all along the eastern coast, even up to the coast of Kerala, where we get the resources of thorium in the form of the monazite bearing sand, beach sand, there are many such important occurrences on the coast of Odisha. And in fact, this particular type of deposit makes us one of the major in terms of the thorium resources, which has given rise to the technology of thorium based nuclear power plant that is already in order. And such kind of so these kind of placer occurrences, they sporadically occur in many parts of the coastline in India, from the eastern coast, from Odisha coast to all along to Kerala, where the famous Quillan beach is very well known for its rare earth element occurrence. We do also have this beach placer coming as a rich source of titanium. There are ilmenite bearing sand which also do occur in many parts of the eastern coast. And they are going to be the most rich resources of titanium for our domestic consumption and for industrial purposes. So these are the ones which so along with the bauxites, beach placers and the bauxites, which is basically the very well known east coast bauxite. Occurring in the southern part of Odisha and further to the south. So these only are the ones which are the deposits which are young in the quaternary. Otherwise, rest of the metal resources, which are our resources of iron, gold, chromium, manganese, lead and zinc, copper, lead and zinc, uranium. So most of these deposits mostly are in the Precambrian. They occur along with the Precambrian rocks, and so that's all about the situation that we can depict about the mineral potentials of the country. The important localities for very active and further exploration are the coastal areas for their accumulation of rare earths and titanium, and the vast tract of granites which are as yet not known to be mineral potentially deposit bearing. They also do provide a lot of scope for further exploration, and if such exploration efforts are continued, we could possibly be able to discover a few more such deposits and to meet the demand of many of the metals in the country. So, that is all about the a very brief overview of the metal or the mineral potential of the Indian subcontinent, bearing some of the deposits in extrapeninsula, like in the there are some base metal deposits occurrences from the Sikkim Himalayas area which are reported and were previously also being worked out. Records of old mining activities are there. So, with this I conclude discussion on the Indian mineral deposit. Thank you.